Hey everyone, sorry I can't be there today. We've got a sick kiddo, so I'll definitely be back on Thursday. Um, what you're doing today is just the very intro basics to what are called limits. We'll get into what's called limits and continuity. We'll talk more about the details as we get forward, as we move forward. This lesson is very, very straightforward once you understand the basic concepts. You're just doing input-output tables and determining limits with graphs. So I could have just given you the notes, but the big thing is I just wanted to make sure you understood the concepts of what we're doing with a limit. So the idea of a limit as we approach some x value. So like if I say what is f of 2, you're asking what is the output at an input of 2, obviously. Uh, that is different. What a limit is different than that. So first off, what is a limit? Well, let's take this function and just note why there's a hole at the x value of 2. If I factor the numerator, cancel, we now have f of x equals x plus 2, and that's why we get this line, and it has a hole here because it has a hole at the x value of 2. So we have no output. But if we do what's called a limit. A limit is saying we are as a limit as we approach some x value. In this case, we're going to approach the x value of 2. Let's draw like an imaginary line at the x value of 2. And now we divided the graph into two regions, the left-hand region, or the negative region relative to 2, and the positive region, or the right-hand side relative to the x value of 2. And the first thing when we're doing a limit, what we're doing is imagine like there's someone walking on a graph. I just like to say an ant. An ant is walking on a graph and approaching the x value of 2. And as they walk on this line or this graph, as they're approaching the x value of 2, what y value are they getting very, very close to? That y value would be 4. And this would be the same with the right-hand ant as well. The right-hand ant starts at positive infinity and walks towards the x value of 2, and the y value that it would be approaching is 4. And therefore, that means that the limit as x approaches 2 of this function is equal to 4. And that's what this notation means. And you see this? This is the x value you're going to be approaching. This is whatever the function is. You have the graph of it. And whatever those two values are approaching on both sides is your limit. Now we're going to get into some more specifics in terms of what input-output tables are going to look like, and also as we get more complex with limits, which doesn't really get that bad, believe me. You'll see what that looks like in terms of finding limits with graphs. Okay, so on your homework you have maybe one or two input-output tables where the x values are going to be determined for you, and then you just got to find the y values, which are just simply outputs for each of those inputs. You'll see what I mean. So if you look here, they're just asking us find the limit as x approaches -3. Why -3? Well, maybe it's a key point on the graph, which you may notice because the denominator is x plus 3. It really doesn't matter. It's just asking us to do it. And for an input-output table, this is kind of like our base case for how we can determine limits. And the way we do it is like in this middle one, it will have it done for you already. We are going to start with 3 decimal places of a value just less than -3, and then to the just greater than -3, 3 decimal places. And then you don't need to know how to do this. I'm just explaining what you'll see on your homework. Then you'll have one with 1 decimal place, 2 decimal places, and then 1 decimal place. And then the other side, I'm going to explain this all the way here in a second. -2.99, -2.9. Now keep in mind that the -2.9s and so on are greater than -3, and the -3.1001 and so on are less than -3. Okay, so why are we doing this? What we're doing is we're seeing numerically in a table as we're getting really, really close to -3 on this side, and as we're getting really, really close to -3 on this side, we want to look at what are the y values approaching. So you simply plug these values in, and you get outputs. and you're going to fill in the outputs, and then you're going to see like, oh, what are these two values? What values are we getting closer and closer to? And that's our limit. So my suggestion for getting these values, if you go to Desmos graphing calculator, graphing, graphing, and you go y equals, and you plug this in. Just gotta be careful, it's not the easiest to plug in. I don't remember what they were on the homework, it shouldn't be too bad. If you plug that in, and then you hit that settings button, you know, like looks like an Apple settings button, you click that, and then you'll see a table. Then table icon, click the table. I think you may have done this before, but in any case, you can click that, and then a table will show up, and then you literally just insert each one of these values into the table, and the outputs will be staring you in the face, and then you just put it into the table here. So I have like negative 0.248. And then I have negative 2.249, and then negative 0.2499. I'm going to put the arrows here indicating like, oh, the and from that left-hand side is getting closer than that. And now I'm going to look at this, and I get negative 0.2500. At this one, I get negative 0.2501, and then this one was negative 0.2515. And so we look at this and we see, oh, it looks like these are getting closer to negative 2.5, and these are also getting smaller and smaller, getting closer, and therefore, based on that input-output table, we can make the prediction that the limit is negative 0.25 or negative 1/4. So now what does it look like to determine limits with graphs? Very similar to what we did before. So A here, note there's, again, a difference between a limit and an output. A limit is saying, okay, at that x value of 2, sorry it's sloppy, I'm writing the iPad, I am going to draw a dotted line at the x value 2, and it just happens to be the vertex. You could do it at any other value, x equals 1, x equals 4, blah, blah, blah. Do the same thing. And so when we do this, we're saying at the left-hand side, this ant, as it approaches that x value of 2, what y value is it getting closer into? And then same with this one. That ant, they are both approaching the y value of negative 2, so the limit is negative 2. Also, if I just give you f of 2, that's the same, what is the output at 2? Well, the output we know is negative 2. So, in this case, the limit and the output are exactly equal. That's not a very interesting case. We're just still trying to get the basic functionality of calculating limits off of graph. What happens now when things get a little more complicated? What will it look like? So let's go ahead and take, and note, anytime I write limits, I'm typically going to write it with a cursive L, just so it doesn't look like a 1. Maybe not all the time. So now we're going to look at x equals 1. Actually seems like a relatively interesting case, given we got that open circle and a close there. So the limit, I'm going to, as x equals 1, I'm going to look at the ant getting closer and closer to the x value of 1. That's approaching 3. And then this side, that ant is also approaching 3. So the limit as x approaches 1 of f of x equals 3. Then for letter B, I want to find out what is f of 1. What is the output at 1? And the output we see is 2. So here's a case where the limit and the output are different. Okay, hardest thing you're going to have to do on this, and we're introducing new notation. That's fine. Hardest thing you're going to have to do here is graph a piecewise function, which compared to the beginning of the year, it probably doesn't seem as bad as it did then, even though we didn't really have too much of a challenging time with it. But in any case, okay, so just go back to the basics of graphing a piecewise function. I definitely suggest using an input-output table. We want to first start at the value of 1 and plug that in, rather than thinking, oh, there's a parabola, I'm moving up, and instead of using those techniques, I think it's just base case, use input-output table until you get a good enough estimation, and then you can, 2 or 3 points, and then you can sketch a graph from there. So if I'm going to plug in 1 in for here, if I plug in 1, that gives us an output of 2. So that would be the coordinate 1, 2, and note that's going to be an open circle, and that open circle is because it's not equal to there. We're going less than 1, so now I'm going to plug in 0, or you just plug in any values you want. Let's pick the easiest. So 0 plugged in will give us an output of 1. If I plug in negative 1, that would also give us an output of 2. And hopefully we see now that there's a parabola. Of course, you could keep doing more values, or you just graph it like that. For the second case right here, we plug in 1 in for here, and we get out 4. and it gives us an output. And then we have a slope of 1. Like I said, you could just use, it's a line. We have a slope of 1, so we know we're going to go up 1 over 1. But again, if you just base case use input-output table, if I plug in 2, that would give us out 5. If I plug in 3, that would give us out 6, and there we have our graph. So now we are going to do the limit, where it now says limit as x approaches 1 from the negative side. What does that mean? That means this negative right here means the left-hand ant. You may have remembered doing limits back in rational functions last year, but I know sometimes our remote learning was a year of amnesia, which is fine. So that being said, this negative is saying, okay, if we go over to the x value of 1, we make our division line right here. We are talking about the ant that's approaching this from the left-hand side. So we look at this ant approaching, it's getting closer and closer. What value is it getting closer and closer to? And that answer is 2. I'll do that again. As this gets closer and closer and closer to the x value of 1, what is the y value that's getting closer and closer to? That answer would be 2. Now, the next one, as you see, letter C, it says limit as x approaches 1 from the positive side of f of x. This is now talking about the ant approaching from the right side. So again, here's our division line. I'm not going to draw it. I'm just going to kind of illustrate it right here. So coming from the right side would be an ant coming all the way from positive infinity, getting closer and closer and closer to the x value of 1. I think I said 2. I meant 1, sorry. The x value of 1. And as we get closer and closer to the x value of 1, this one is approaching what y value? And that's a y value of 4. Now the last question, and note that 10 right there. That 10 is just, that's part of the scaling of the graph, so not the best formatting there, my apologies. So now we have limit as x approaches 1 of f of x, which means when you have this overall limit, that means both of the ants. What is the left and the right-hand ant approaching? Now in the previous problems, both the left and the right-hand ant were approaching the same value. Now they are not. The left-hand ant is approaching 2, the right-hand ant is approaching 4, and therefore they are not approaching the same value. And now we get our Mean Girls reference of the limit does not exist, DNE.